Hey everybody, Mr. Lambert here with today's Math Spiral in Review for let's say Tuesday, September 15th, 2020. Today we're going to be computing with non-integers again. So again, we're dealing with all that stuff we're working on in 6.c.2, being able to fluently add, subtract, multiply, and divide fractions, decimals, and percentages. So we're going to deal with decimals mostly today and do a little review of what we've been working on, which is the multiplication of fractions. So let's get going. All right, first one, I got 13 and 5/10 plus 4 and 76 hundredths. Keep in mind what you're going to have to do. You're going to have to line those numbers up. You may have to add a 0, hint, hint, with that 13 and 5/10 in order to get to line up with your 4 and 76 hundredths. So go ahead and give this one a shot, and we'll check it here together in just a moment. All right, let's see what we got. I'm going to rewrite it out. Now again, because I have two digits, I have a hundreds place in my second number down here, I am going to add a 0 to hold place. And 4 and 76 hundredths. Now, if yours does not look like this, it needs to. You need to line that up with something because you need to know that we're going to have to account for that lack of space. So 6 plus nothing is 6. 5 plus 7 is 12. We're going to take that 2 here, put our decimal point in because it goes straight down, and carry our 1 over. 3 plus 1 is 4, and another 4 makes 8. And 1 plus nothing is 1 in our tens digit. All right, so we got 18 and 26 hundredths. Again, that should be about right because this is right around 13 and a little over 13, and this is a little less than 5. And 13 plus 5 would give us 18. So this should be a very reasonable answer. All right, let's move on to our second problem here. We're going to do a little bit of subtraction. Same deal. Make sure you're lining your numbers up. Make sure you add zeros where you need to. Go ahead and give it a try, and then we'll check them out. All right, here we go. Got 81 and 32 hundredths. But because I have thousandths in my bottom number, I'm going to drop a 0 there to save my place. Then 17 and 221 thousandths. If you guys didn't know, I hate drawing with the mouse. All right. Nothing minus 1. Well, we can't do that. Can't take 1 away from nothing, so let's steal from over here. 10 minus 1 is 9. That we can do. Now I have 2 minus 1. Yeah, 2 minus 1. No, 1 minus 2. That's impossible. So let's steal again. 11 minus 2. Hey, another 9. 2 minus 2 will give us nothing. There's a big old goose egg there. And my decimal point, again, same as with addition, it's going to move straight down. So my decimal point will go here. Can't do 1 minus 7. We're going to have to borrow again. Man, Mr. Lambert, didn't think this one through. That's a lot of borrowing. 11 minus 7 is 4. And 7 minus 1 will give us 6. And again, I can tell this one's fairly reasonable because this is a number right around 80. And if I were to subtract 20 from 80, I would have something around 60. And because this is a little less than 20 that I'm taking away, my answer should be a little more than 60. So 64 and 99 thousandths is a very reasonable answer. All right, moving on. Multiplication. 9 and 61 hundredths times 2 and 9 tenths. Go ahead and give that a try, and we'll work it out here in just a moment. All right, so 9 and 61 hundredths, let's rewrite over here, and 2 and 9 tenths. Now, I'm not even going to worry about lining up my decimals because it's not important when I'm dealing with multiplication and division of decimals. Remember, all I have to do is make sure when I'm multiplying that I have as many decimal points in my question as I do in my answer when I'm done. So we're going to worry about that later. 9 times 1, we're going to run just the standard algorithm for multiplication. So we'll deal with our 9 digit first. 6 times 9 is 54. Carry our 5 over. And 9 times 9 is 81, plus another 5 makes 86. So that was pretty easy breezy. I'm going to drop a 0 here because even though this is a 2, I'm dealing with tenths over here. So we're going to treat everything like a 1 and forget those decimals are there. If this was a 20, we would add a 0 in to hold our place. So I can now treat this like a 1. 2 times 1 will give me 2. 6 times 2 is 12. Carry the 1 up. 9 times 2 is 18, plus 1 gives me 19. And that's where we... Wait, no, hold on. I got to carry my 1 over here, don't I? 2 times 5 is 10, and 1 more is 11. Wait a second. That wasn't there. That 5 went with my 2 times 9, which would be 18 plus 5 more. Sorry, would give us not that. 18 plus 5. Sorry, we don't have to worry about that 5 because that was from over there. 18 plus 1 is 19. There we go. This is going to be a much more reasonable answer. So we have 9. 4 plus 2 is 6. 6 plus 2 is 8. 8 plus 9 is 17. And 1 plus 1 is 2. All right, so I have 2, 7, 8, 6, 9. I've got a lot of digits. And now I need 1, 2, 3 digits behind my decimal point. So 1, 2, 3 over 27 and 869 thousandths. Is that reasonable? Well, yes, because 9.61, we could round that down to 9. And if we rounded this guy up to 3, 3 times 9 is actually 27. This one's a little bit low. This one's a little bit high. So our number being a little higher than 27, that is reasonable and it makes sense. All right. Moving on. If I pick the right tool. Division of fractions. All right. Hold on. This is multiplication of fractions. I saw that fraction and thought division. Multiplication of fractions, which is good because we haven't done division yet, right, guys? This is actually what we're going to be doing today, and I wanted to see if you guys could get a little jump on it. So think about what we did yesterday. That's going to be your hint. In this case, we have 2 fractions, right? So we're not even going to worry about having to put this number over 1 because we already have a fraction. Just think about what your algorithm was and give it a try. All right, let's see how you did. Remember, this is participation points. You don't even have to get this right. All right, 3/9 times 1/3. Now, if this were 3 over 1, or if this were 3, we would put our 3 over 1. Because this is the inverse, we actually have digits in our numerator and our denominator already. We don't have to mess with our number at all. We can just multiply straight across. 3 times 1 will give me 3. 3 times 9 gives me 27. So 3/27 is kosher, or if you wanted to, you could simplify this by dividing by 3 over 3, and we would get 1/9. There you go. All right, ladies and gentlemen. Got one more. We have division of decimals. So 4 6/10 divided by 3 2/10. Remember, when you're dividing by decimals, you need to make sure that your divisor, or your number outside the house, is a whole number. Think about how you need to mess with your decimals in order to do that, and we'll check it here in just a second. All right, let's go. So I've got 3.2 or 3 2/10. We'll put this outside of our vernaculum. Inside, we're going to have 41 6/10 is our dividend. All right. Got our divisor, our dividend, we're good to go. Now, we do need to fix our divisor because it is a decimal. So I'm going to move this decimal point to the right one spot. That makes this number 32. I can do that as long as I do the same thing through my dividend. So that is going to become 416. Our decimal point moves over to here. So unless we need to go past this point in order to get our answer, we don't really have to worry about him too much. Now I'm just going to treat this guy like a 32. 32 into 41. And I can do that. Can't do 32 into 4, but I can do 32 into 41. I actually can put one group or take one group out there. If I do this, I have to borrow from my 4 to make that a 3 and that an 11. So 11 minus 2 is 9. Our new 3 minus 3 is nothing. And I'm going to drop down my 6. All right. and 32 into 96. Well, if I'm thinking 3 into 9, let's try that. That would be 3 times. Let's give that a shot and see if that works. 3 times 2 is indeed 6, which is good, lining that up. And then 3 times 3 is 9. Excellent. Subtract that out, and I get nothing for my remainder, so I don't have to worry about any of my digits over here. Our answer is 13. All right, ladies and gentlemen, that's it for your spiral interview today. Hopefully that was helpful. A little bit of a reminder of what we've been working on. Today, again, we're going to be working on multiplying fractions times fractions. Again, it's pretty much like fractions times whole numbers, except for part of the work is done for you. Your whole number already looks like a fraction. Where the whole number was last time, it's already going to look like a fraction. You don't have to mess with anything. You are just going to multiply straight across. So watch the video below, try a few questions out, and we'll get going on that guided practice right below. All right. See you guys in a bit.